Hi friends, in this video we solve Terminus Theorem related problems which will be useful for TRB and GATE exam. Right, so let us see. First problem is determine the current through 2 ohm resistor using Terminus Theorem. Right, so this is a current through 2 ohm resistor. This is a 2 ohm resistor. So I have to find this current I. This is what my aim. Right, so whenever we want to apply Thevenins theorem, we have to find see what is the main advantage of Thevenins theorem. It is used to find a current through a particular branch, and we can replace a big circuit with a simple voltage source, which is nothing but V Thevenin, and one equivalent resistance R Thevenin. This is our RL, right? So here, what is V Thevenin? It is nothing but open circuit voltage. That is Thevenin's voltage. R Thevenin is equivalent resistance. Let us see how to find all the things. Okay, right. So this circuit can be replaced with only one single voltage source and equivalent resistance. This is considered as our RL because through this only we are going to find current. Okay. First, what we have to find is we have to find Thevenin's voltage. Right, Thevenin's voltage is nothing but an open circuit voltage. So which one we have to open it? This load resistor we have to open it. So let me read the diagram. So this is like this. This will be like this. I open it. Right. So here only we have to find the voltage across the load resistor is nothing but open circuit voltage. Right. Okay. Now this is a circuit. Fine. Right, this is 6 volt, 1 ohm, 1 ohm, right? It is 12 volt. So I have to find what is the voltage across this circuit. So I apply KVL. Apply KVL because it is only single loop, so we can directly find the current flowing through the circuit. From this, I have to find what is called voltage across this load resistor. So here, from here, we will start. So what happens? This is current flowing through this. This will assume plus minus. So from here I will start, right? So I into 1, here I into 1, here plus 6 volt, here it is coming and going through my negative terminal, so minus 12. This is equal to 0. You see the current starts from here. Let us assume that first it encounters plus terminal, so positive I into 1. So I find the voltage, so I into R. Similarly here I into R. Here the voltage is given plus 6. Current enters through positive terminal plus 6. Here current enters through negative terminal minus 6. So this implies I is equal to 3 ampere. Right, so I is equal to 3 ampere. Next, what I have to find? We have to find voltage across this, right? So how can we find voltage across this? See first, what is the voltage across this terminal, right? So voltage across 1 ohm resistor. This 1 ohm resistor is V is equal to I into R. So 3 into 1, 3 volt. Fine. So next, what is the voltage across this terminal? This is also 3 into 1, 3. So what is the voltage across this terminal? So it is 12 volt. Here 3 voltage drop. So the voltage across this terminal should be 9 volt. So here we should feel 9 volt. Let us assume this is the point AB. So voltage across AB is 9 volt. Here we see what is the difference between the voltage potential difference between these 2 points. It is 12 volt, 9 volt. Here 3 volt. Yes, we know the voltage across this one is 3 volt. Similarly, you see what is the difference between the, because current flowing from here to here. So here higher potential to lower potential. So here 9 volt, here 6 volt. What is the drop? 3 volt. That's what we have found here also. So the voltage across AB is 9 volt. That is what our Thevenin's voltage, V Thevenin. So just we got V Thevenin. Next, what we have to find? We have to find R Thevenin, Thevenin's resistance, right? So how to find R Thevenin? R Thevenin is a resistance which is obtained by removing all the sources by its internal impedance. Voltage source has an internal impedance of 0, current source has an internal impedance of infinity. So make voltage source short circuit, current source open circuit, and remove this what you call load resistance. So the circuit will become, this one should be shorted, this voltage source. This one should be shorted because this is also voltage source, right? So, and this must be removed. So remaining thing will be this 1 ohm. So R Thevenin, if you want to find R Thevenin, the circuit will be like this. It will become like this. So this is 1 ohm, this is 1 ohm. So R Thevenin is equal to 1 ohm parallel 1 ohm. If two equal resistance are parallel, then resultant resistance will be half of the resistance. So R Thevenin is 1 ohm, 0.5 ohm. So we got V Thevenin, R Thevenin. What is our equivalent circuit? I told equivalent circuit will be this one. So R V Thevenin, we found V Thevenin is 9 volt, right? R Thevenin is 1 ohm, RL is 2 ohm, right? So what they ask, current through the 2 ohm resistor, right? So current through the 2 ohm resistor is, see what is the, sorry, it is 0.5 ohm, right? So what is the total resistance? This is current only, current through 2 ohm resistance. So I is equal to V by R, total resistance. So V is 9, R is 2 plus 0.5, right? So that will give 3.6 ampere. So 3.6 ampere is the current which flows through this R. You see, the circuit is replaced by, see, this circuit has 3 resistor and 2 voltage, so that is replaced by a equivalent single voltage source and a resistor. That is the beauty of advantage of what you call Thevenins theorem, right? Okay. Next question is, determine Thevenin's equivalent across AB. So we have to find Thevenin's equivalent across AB. Fine. How to find? So directly we cannot find. We have to redraw the circuit in a different fashion. Then the problem will become simpler. So I redraw the circuit. So it will be, this one will come up. So it will come up, right? So sorry, here in the problem they gave minus. Fine. So it is minus. So when I redraw, it will become plus minus, and this top will come to bottom. Fine. So it will become 12 ohm. It will become 8 ohm, right? So A comes here. This bottom comes here, so it will go like this. Then it is coming like this. 1 ohm, 9 ohm, right? Here it will be like this, plus minus. Here 10 volt, right? Okay, this is 20 volt. Okay, so now it is very easy. First, what we have to do, whenever you want to find voltage across AB, right? That means, determine Thevenin's equivalent. First, we have to find V Thevenin. V Thevenin is nothing but open circuit voltage, right? So, what we have to find the voltage in this V, right? Let us draw open circuit voltage. So, voltage. Let us assume this voltage across A and ground is V1. Voltage across B and ground is V2. Fine. Okay. Okay. Let us see. First, we have to find voltage across AB only. That is open circuit voltage because it is acting as a load. So here you see, I apply KVL here, I1. So what will happen? 20 I1 is equal to 20. This implies I1 is equal to 1 ampere. Similarly, for this I2, right? So I apply KVL at second loop. So 9 plus 1, 10. So 10 I2 is equal to 10 ampere. This implies I2 is equal to 1 ampere. This indicates, see, this is the voltage. What is VA? The voltage across A and ground. So VA, voltage at point A is, node A is VA, that is given by the current flowing through this is I1, that is 1 ampere. Resistor is 12, 12 volt. Similarly, VB is the voltage at this node. It is current flowing through this resistor is 1. If VB is the voltage across this terminal, right? This one and this one. So 1 into 1, 1 volt. So what I need is VAB, right? Because we have to find voltage across A and B. So that is our voltage, open circuit voltage, which is nothing but our Thevenins voltage. So that is equal to VA minus VB. 12 minus 1 is equal to 11. Right? So this is Thevenins voltage. What about Thevenins resistance? What we have to do? We have to remove so independent sources by their equivalent circuit. Replace voltage source by its internal resistance and replace voltage source by this internal resistance. Both are having internal resistance of 0. So I redraw the circuit for R Thevenin. So it will become like this, right? So it is 12, 8, fine. It is, sorry, here it will be 8 ohm, here it will be 12 ohm, here it will be A, and here I replace with the, this will be like this and this will be like this. So it will be 1 ohm, this will be 9 ohm. So this is B, right? So I replaced the voltage source, replace voltage source, or we short it, make current source open circuit. So now we got V Thevenin. What about R Thevenin? This is what R Thevenin. So these two are parallel, these two are parallel combination. So R Thevenin is equal to 8 parallel 12 plus 9 parallel 1. We know how to make it simple. So it will be 4.8 plus 0.9. So that will be 5.7. So we got R Thevenin. So what we have to do? We got V Thevenin 11 volt, R Thevenin 5.7. What they ask is find the Thevenin's equivalent. So what is the equivalent circuit? We can draw V Thevenin 11 volt plus minus R Thevenin is 5.7 ohm across the terminal A and B. Simple. Right? So in this way we can solve this problem. Okay. Third problem, what they ask here, in the given figure, the Thevenin's equivalent pair as seen by terminal P and Q, right? So we have to find the Thevenin's equivalent across this terminal. So first what we have to find, I read first I find Thevenin's voltage, which is nothing but open circuit voltage. So this one like this is like this, right? So this will be this one. So 10 ohm, 10 ohm, 4 volt, 20 ohm. So open circuit voltage means open the load. So what is the voltage across this terminal is open circuit voltage, right? So let us assume I want to find, if I want to find VTH here, I can find what is voltage across this. So let me apply KCL. Let us assume the no voltage at this point is node is V Thevenin. So I apply KCL for this branch, V Thevenin by 10, right? Plus for the next branch, this one, V Thevenin minus 4 divided by 10 is equal to 0. This implies V Thevenin is equal to 2 volt. So we got V Thevenin. Next, what we have to find? We have to find R Thevenin. If I want to find R Thevenin, I have to replace the voltage source by shorting it. So this one, I short it. I shorted voltage source. This one and this one. 20 10, 10, 10. This is the R Thevenin, right? So here you see these two are parallel. A resistance parallel with the short will become 0. So here it will be 0. Now these two are parallel, 10 into 10. So 10 parallel 10. So 10 parallel 10. So that will give 5 ohm. So R Thevenin is 5 ohm. Fine. V Thevenin is 2 volt. Right? So what they ask, equivalent circuit, R Thevenin 5 ohm 2 volt. So option 5 ohm 2 volt. Option A is the right answer. Right, next question is, as shown in the figure, yeah, 1 ohm resistor is connected. 1 ohm resistor is connected across a source that has a load line of V plus I is equal to 100. So V plus I is equal to 100. Find the current through resistance I. Okay, find the current through the resistance. So we draw Thevenin's equivalent. You see, because this is a big circuit, we have to replace by Thevenin's. V Thevenin. So I want this resistance R Thevenin and voltage across this. Okay. So first let us find open circuit voltage. V Thevenin is nothing but open circuit voltage. So VOC. When when a circuit is open, I is equal to 0. We know that, right? So open circuit voltage means current is 0. So current 0 means I0 means V is equal to 100. That's what open circuit voltage, because I0. Similarly, we find short circuit current, ISC. Why we find short circuit current, I will tell you. Right? If a current is short circuit means V is equal to 0. So if we substitute V0 here, I will become 100 ampere. Right? So we know VOC and ISC. There is another way to find R Thevenin. R Thevenin can be obtained by using the formula R Thevenin is equal to VOC by ISC. So we got both. Right? This is another way to find R Thevenin. R Thevenin is the ratio of open circuit voltage and short circuit current. Open circuit voltage is 100, short circuit current is 100. This implies R Thevenin is 1 ampere, 1 ohm. So R Thevenin is 1 ohm. V Thevenin is open circuit voltage 100 volt. Right? So now the circuit is replaced by V Thevenin 100 volt plus minus R Thevenin 1 ohm and the load is 1 ohm. What they ask, current through 1 ohm resistor. So I is equal to V by R. V is 100, R is 1 plus 1. So 50 ampere. So the answer is 50 ampere. Okay, simple problem. And the next problem is find the Thevenin's equivalent circuit across AB. Right? So this is another simple problem. Let us see. Right. First, as usual, we find open circuit voltage, right? Or Thevenin's voltage. Thevenin's circuit voltage is nothing but open circuit voltage. So first we have to open it. Okay, this is 9 ohm, right? Voltage across AB. So this only acting as a load. So open it. I have to find it. So this will be 7.5 ohm, 6 ohm. Fine, and this is opened. This will be like this. This will be like this. This will be like this. This is 30 volt, 5 ohm. Right? I have to find a V Thevenin across this. Fine. Okay. So let me apply KVL to find voltage across this terminal AB. Right? So let us assume the current flowing through this is I1. Here current flowing through this is I2. Okay, right. So I want to solve this. First I apply KVL for this loop, or I apply loop analysis. So what is total resistance? 12.5, right? This is it is I applied loop analysis for mesh analysis for these two loop. So here total distance is 5 plus 7.5, 12.5. Common is 7.5, so it is minus 7.5. Shortcut, it is minus 7.5. Here total resistance is 9 ohm. It is 9 ohm. So 9 plus 6, 15, 22.5, right? So 22.5. So here the current flowing through is I1, here I2. R into I is equal to V. So here voltage is 30 volt. Here it is 0 volt. Fine. So by using this, you find I2. It is a simple matrix. So use Cramer's rule. Use that and find I1 and I2. I1 is 3 ampere. I2 is 1 ampere. Right. So I want VThevenin. So I1 and I2 I found. What is VThevenin? VThevenin is the voltage across this terminal. So what is the voltage across here and what is the voltage across here? So VThevenin is equal to voltage drop across 6 ohm resistor plus voltage drop across 5 ohm resistor. So here what is the current flowing through this? Here the current flowing through this I2 current. So I2 is 1 ampere. So 6 into 1, 6 into 1 plus here I1 is 3 ampere, 5 into 1, 5 into 3, so 8, 15 plus 6, 21 volt. So VThevenin is 21 volt. Next what we have to find RThevenin. RThevenin, that is very simple to find. We know all the internal resistance should be replaced, all the voltage source must be shorted. So this one will be removed as it is. So this one must be shorted. 7.5, 5, 9 ohm, 6 ohm. So RThevenin is, we know that these two are parallel. 7.5 and 5 ohm are parallel. 7.5 parallel 5, right? And this is in, right? Once it is simplified, what you get is 3 ohm, right? So that once I simplify this, I get it, it will become 3 ohm. So it is becoming, right, like this, 3 ohm. This is 9, 6, 3, and this is our AB. So this AB, it will be like this, AB. So what happens? Now 9 and 9 are parallel. So R Thevenin, say R equivalent. Now R Thevenin 9 parallel 9, that is equal to 4.5 ohm. Because when two equal resistance are parallel, the equivalent resistance is what you call half of the one resistance. So VThevenin, RThevenin is found. So the circuit is replaced by what you call VThevenin 12 volt, sorry 21 volt. 21 volt, RThevenin 4.5 ohm. Here it is coming like this. Load resistance is AB, right? So what is the load resistance as per the problem? 1.5 ohm. So it is 1.5 ohm. 1.5 ohm. So this implies I is given by, this is the equivalent circuit, Thevenin circuit. If you want I, just find 21 by 6, 7 by 2, 3.5, right, ampere. That is the current flowing through this. So this is the equivalent circuit. This is the current flowing through the circuit. Okay, next one, find the Thevenin's equivalent circuit of the given figure. So we have to find the Thevenin's equivalent circuit. So as usual, first what we have to find Thevenin's voltage, which is nothing but open circuit voltage. So where is A and B? So I didn't draw this. This is A, this is B. So this is what they ask. Find the Thevenin's equivalent across circuit across AB, right? So we have to find it. Okay, first we find the Thevenin's voltage. So this circuit is remaining as it is because the load is already open only. So I have to find the voltage across AB is Thevenin's voltage, right? Okay, how can we find? You see, VThevenin. First we find this is VA, right? First we find VA, right? To find VA, I have to find what is the voltage across this terminal. So V 2500, that is given by total voltage. I apply voltage divider rule, right? So what is the voltage across 2500 only I have to find. So first I write that 2500 divided by total distance 2500 plus 500, right? So and multiply by total voltage 10. So it will give 8.33 volt. I applied voltage divider rule. Similarly, what is the voltage across 1050 here? Then only that is EBB, right? So what is the thing happens? So what is the voltage across 1050 I have to find. So 1050 divided by total voltage, the total resistor, 1050 plus 200. So 1050 plus 200 multiply by total voltage 10. So that will give 8.4 ohm, sorry 4 volt. So what is VAB? VAB is our VOC or VThevenin. VA minus VB. So 8.33 minus 8.4, that is equal to minus 0.07 volt. So minus has come, that means what? It is 0.007 volt with the AAS positive. Here you see, like that we have to change, because it is minus, potential cannot be negative, so it must be plus 0.007 volt with the A is leading positive terminal. That is a simple logic. And next what we have to find, RThevenin. RThevenin, what we have to do, we have to replace the voltage sources by its internal resistance, so short it and redraw the circuit, right? And this is opened already. Okay, so if I redraw, the circuit becomes like this. So it will be going like this. It is 2500 ohm, this is 500 ohm, this is 1050 ohm, this is 200 ohm, right? So what I do here is, you see, uh, this is AB, that should be taken out. So I, instead of drawing inside, I draw outside. I just redraw the circuit. Okay, so AB will be coming like this. This is A, this is B. So AB. Instead of going in, I have taken outside. What about this fellow? The voltage source is shorted, no? So it will be coming. It will be like this. It is shorted, right? So instead of it is being outside, I bring inside. So it is lying between, let us assume this is C and D. So this lies between C and D. C and D are shorted. So what I do, this is C, this is D, so that terminal is short. Okay, now you see R equivalent we have to find. So R is given by RCD. First we have to find, you see 2500 and 500 are parallel, right? So that is what R Thevenin is. So I read again. So 2500 and 500 are parallel. That is in series with the, you see, 1050 and 200. 1050 and 200. Right? You see, these two terminals are in parallel. Right? Similarly, these two terminals are in parallel, that are all connected. Here A, here B. So what is RThevenin? RThevenin is nothing but 2500 into 500 divided by 2500 plus 500 plus 1050 into 200 divided by 1050 into 200. So that will give RThevenin is equal to 584.66 ohm. Now we got everything. So VThevenin we found, Thevenin is what we got 0.007. So Thevenin 0.07 volt, Thevenin 584.6 ohm across EAB. So the big circuit is replaced by single voltage source and resistor. This is Thevenin, this is R. This is the biggest advantage of what you call Thevenin's theorem. Fine. So this is very simple question. I hope you understand everything. If you have any doubt, please ask me in comment section. I will clarify. Thank you.